Hello everyone, so again we are back on my YouTube channel Quest Achiever. Uh, we are dealing with the digital electronics series. In that we are dealing logic gates. So this is sixth logic gate, that is XOR gate. We studied NOT gate, AND gate, NOR gate, OR gate, NAND and NOR. So basically you study that also, then you come with the XOR gate. See, basically and OR and NOT gate, these are the basic gate that you need to remember, because using that only you can make any of the gate. Okay, and then NAND and NOR, similarly NAND is like basically NAND is basically AND plus OR. Similarly NOR is basically OR plus NOT. This is how it made. And then we are studying like XOR gate. XOR gate is quite simple. Okay, this is also a simple gate, but in gate exam, in ESE, many exams are there, electronics based technical exams are there. In that this gates question, this XOR gate questions have many weightage. Okay, like XOR gate, first symbol, listen the symbol, just see the symbol diagram and listen the points what I'm telling it. Okay, just see the symbol how it looks. So this is called as XOR symbol, y is equals to A XOR B. Okay, this is how you can write it. Even you can write XOR like A bar, okay, A B bar plus A bar B. This is in SOP form. I will tell what is SOP and pause in next class. Okay, next means in coming videos. Okay, and this is also you can write in this way also. This is in pause. SOP and FOP, I can just tell now. Just remember till this class, just remember the full form. SOP is basically sum of product and pause is basically product of sum. Understood? So this is how it can make. Now we'll study the truth table. I will just tell you how the SOP and pause are related, and how basically these all terms are there in the K-map. So that's why I'm more emphasizing on that SOP and pause in that lecture only. Okay, so that's why I'm just remember the full form and we'll study deeply in K-map class. Okay, just listen the truth table. Here the truth table is really important. Rest thing is really simple, but the truth table is important. How the XOR give response when two of the inputs are same, different. Okay, just listen. When in XOR, when any of the input are same, like 0 0, then it gives 0. Like any of the input is different, like 0 and 1 or 0, then it gives 1 1. Both same input means output is 0. Different input, then output is 1. Understood? So this is clear to all. Like same way you can write here also. This is really important. This XOR gate is having many weightage. Okay, I am just telling that that XOR gate is basically like you definitely you will get one or two question based on XOR or XNOR gate. Okay, so here also some I am telling, listen the same, like A XOR A, you will get the output 0, or you can say A XOR 0, you will get the same. Or this A XOR A bar, you will get 1, but A XOR 1, you will get A bar. Understood? I just flipped this. Understood? A को यहाँ पे लाया और यहाँ पे. So see this both are same, that's why you getting 0. Means whenever you XOR A with 0, then you will get A only. Whenever you XOR A into A bar, A XOR A bar, you will get 1, or A XOR 1, you will get A bar. Understood? That is a really important part. So this XOR basically, see here I am telling some properties about the XOR. Just listen carefully. So this XOR, whenever the input is odd, see this is total 1 including A and B. See, 1 is 1, here also 1 means odd. Okay, so this XOR is basically, it is odd parity detector. odd parity detector. Odd parity detector. Why odd parity detector? Because here see 0 or 1. So 1 means only one is there, right? So that is odd. See, here also here 2 odd is there, 2 1 is there, that is even. Here none, 0 odd. 0 means you can consider under even only. So 0 देखो यहाँ पे भी 0, यहाँ पे भी 0. That's why it is basically even. Here also 1, 2 1s are there. 2 1s means basically you will get an even number. So even means that is not an even detector. This is odd detector. That's why here totally we have 1. Total we have 1 including A and B. That's why this is a odd parity. Similarly for including input, this 2 is basically an input. Okay, and this is called as input. So only input you can see, including the input part, only the input I am considering. So this is total. How many ones are there? 1. How many 1 are there? 1. That's why it is getting 1. How many ones are there? 2. So that's why it is getting 0. So similarly 2 zeros are there. 2 zeros matlab even. Consider 0 as a even only till now. I know 0 is an integer, but now for the case, now just consider both. How many ones are there? 0 ones are there. So that's why it is given 0. Whenever you will get odd number of ones, then you will get basically 1 high output. Okay, whenever you will get a odd number of ones, you will get high output in XOR gate. Now I am telling about the even parity generator. Even parity generator. What do you mean by even parity generator? Means what? Generator. See, detector means detecting. Whenever here you getting odd number of ones, you will detect high. That is called as detection. Now we want basically even parity generator, including input plus output. Okay, so I think you all understood about the odd parity generator and even parity generator. Okay, so once again I will just revise you. Okay, so odd parity detector means basically, see here in this we have 0 1. Total number of ones is there. Total number of 1 is 1 only. So that is odd. Here also odd. Okay, that's why basically you just whenever they are talking about the detector, just count the input. Just focus on the input. So how many number of ones are there? Only 1. Only 1. Okay, here we have 2 input. Here we have 2 inputs. That's why it is even. So the output will become 0. Output will become 0 here also, because 0 means even number only. That's why. Understood? Detector means total number of input plus output. Input plus output you need to count. So 1 plus 1 2. 1 plus 1 2. That's why it is even parity generator. Understood? Now this XOR gate is also used for basically for what purpose? Using this you will get basically buffer and basically an inverter also. So this XOR gate is really important, because from this you will get basic inverter also and buffer also. How this will work, how this will be used for inverter, just listen. This is my input and this is my floating terminal. Floating terminal, suppose I can give any input like 0, and here I am writing for the another. This is my input and this is my floating terminal. I am providing floating terminal to 1 only. So when input is basically 0 or 1, so 0 XOR with 0, 0 only. 1 XOR with 0, 1 only. So what applied input is 0, then you get 0, 1, then 1. Then means same input getting same output, then you will call this circuit as a buffer. Now I am applying first 0 and then output 1. In this case basically 0 XOR with 1, then you will get 1. Next case 1 XOR with 1, you will get 0. Means applying input 0, you are getting output 1, means it is negation. Means basically you can call this circuit as inverter. So this is the really good advantage of basically what? Good advantage of what? XOR and XOR. Okay, so using XOR you can make buffer circuit. Using XOR you can make basically inverter also. Understood? So in buffer what you need to remember, that in buffer you will get the same input, whatever input you applied. Okay, in inverter you will get different outputs, like 0 is given, then basically you will get one output. similarly 1 then 0. This is called inverter. Buffer means same input same output. Understood? So I think this much is clear. We'll study now XNOR gate. Okay, this is our, for XNOR gate is the last logic gate. Okay, we'll study in the next class. Till then, thank you so much.